Video is topic 4, surface area for Unit 11 exam, geometry. This topic is surface area. We were required by the state of Virginia to know how to calculate the surface area of these 9 shapes. Solids: triangular prism, rectangular prism, hexagonal prism, cylinder, triangular pyramid, square pyramid, hexagonal pyramid, cone, and sphere. Now, as you see, we only have 3 examples here. We're not going to do one of each of these, but we are going to talk about just you're responsible for it, but we're going to talk about generically how we could go ahead and use the formulas provided to you on the SOL formula sheet, which you'll have on the test, to go ahead and help us. So as you can see, I've actually already done example A. We're going to go ahead and walk through what I did here. First of all, I recognize this is in fact a triangular prism. I realize that because there's a triangle on the base. And from my formula sheet, we would know that the formula for a prism is going to be h times p plus 2 times capital B. Well, what does h stand for? H is the height of my shape, as we can see here is 7. P stands for the perimeter of the base, and this capital B stands for the area of the base. So right off the bat, in terms of how I can modify this formula to fit my shape a little bit more, so instead of just thinking about it as the base, to break it up between a triangular, rectangular, and hexagonal prism, is that the area formula for a triangle, for the base of this, is 1/2 base times height. So the base and then the height here. So now substituting in our known values, we can go ahead and say, oh, the height of my shape is a 7. The perimeter of my base comes from adding 6 plus 8 plus 10 plus 2 times the area of the base here. What is the height of the base? It's here. It's of the base shape. It's 6 times 8 times 1/2. Substituting all of this into the calculator, we're able to get 216 feet squared. So for problem B, once again, we are finding surface area. This time our shape is going to go ahead and change. We're going to see that we have a hexagonal pyramid with surface area formula equaling 1/2 L times P plus B. Well, we know what P and capital B stand for. What does this L stand for? Well, in this case, L stands for our slant height. So it's not the height of the pyramid, but it's actually the distance here. We can see that 13 is actually going to be our slant height. 13 here is going to be our slant height value. All right, so we are not going to substitute in values just yet. We actually want to go ahead and make this formula more applicable to our actual shape, in the sense of what's this capital B stands for area of the base. What is the formula for area of a hexagon? 1/2 A times P, where A is the apothem. See right here, of 6.9 is our apothem, and P once again standing for the perimeter of the base. We see this is a regular hexagon because all the side lengths are the same, where 8 is going to be each of the side lengths. Again, the apothem is going to be this value of 6.9. We can now substitute in all the known values. Gives us 1/2 times 13, slant height, plus the perimeter of base is 48, 8 plus 8 plus 8 plus 8 plus 8 plus 8, or 8 times 6, 48, plus 1/2 times the apothem, 6.9, again times the perimeter of the base, 48, gives us a surface area of 477.6 kilometers squared. All right, in example C, we see that we're actually trying to find a missing dimension here, or a missing length. We're actually trying to find the radius, and we're given the surface area. So we're going to start off exactly the same way. We recognize this is a sphere with formula equal to surface area of is equal to 4 pi r squared. Now, in all these other examples, what we've been doing is we've been substituting in our given dimensions and calculating the surface area. Here, we're actually given what the surface area is, so that is our known dimension. So 324 pi is equal to 4 pi r squared. Our only unknown variable here is r, which we can go ahead and start to solve for. Dividing both sides by 4 pi and then dividing out the pi's gives us that r squared is equal to 81. I simply need to take the square root of both sides now in order to get the r value, so r is equal to 9 feet. So once again, we're still using the surface area formula, getting it off of our formula sheet, except here instead of substituting in the known values, we're substituting in what the actual surface area is and any other given dimensions, and solving for the missing length, in this case, the radius.